Good morning. It is time for our math lesson today, Tuesday, May 12th. Today we're going to talk about how to solve measurement problems. So we're just going to jump right in and take a look at some problems here that we have. So let's go ahead and take a look at example 1. So we're working with pages 749 to 752. So you're going to want to get that ready. So I'm going to put here a post-it for me to write down for my 3-read protocol the different information that I need to look for. So remember, we always read a problem 3 times. First, for what is the problem about? What is the math information? And what is the question asking us? And writing that answer in complete sentences. So it says the blue trail, example 1 says the blue trail at the park is 3/4 of a mile long. The red trail is 1 1/4 miles long. Stella wants to hike both trails. How many feet will she hike in all? Okay, so what is this problem about? So it's about a hike, right? So it's about hiking trails. Okay, what is the math information that we are going to use? We're going to use the information that one trail is 3/4 of a mile long, right? And one trail is 1 1/4 miles long, okay? And then the third thing that I have to look for is what is the question asking us? So the question is asking, how many feet will she hike in all? So I'm going to need to say, she will hike blank feet, okay? One thing that I noticed though is that the information it's giving us is in miles. So I'm going to need to keep that in mind as I am solving this problem. So step 1, if I want to know how many miles she hiked, I'm going to have to add the 2 trails together. So if I were to add 1 1/4 plus 3/4, so what they did here is they said 4/4 plus 1/4, and that's your 1 1/4, right? So they converted that 1 whole to 4/4, plus 1/4 plus the 3/4, right? Then they added 4 plus 1 is 5, plus 3 more, and 5 plus 3 is 8. And 8/4 is equal to 2 wholes. Let me show you another way. If we were to add the fractions 1/4 and 3/4, that would give us 4/4. So this would be 1 whole and 4/4. And we know that 4/4 is 1 whole, so this would be 2, right? Okay, so we know that she walked 2 miles, okay? But the question is asking us how many feet she walked. So we're going to have to convert 2 miles into feet. So what we know is that 1 mile is 5,280 feet. So we're going to multiply 2 miles by 5,280 feet. So 5,280 times 2 is 10,560. So Stella will hike 10,560 feet in all, okay? All right, so that was example 1. Let's take a look here at example 2. Example 2 says, Dominic weighed an apple and a watermelon. The apple weighed 5 ounces. The watermelon weighed 20 pounds. How many more ounces did the watermelon weigh than the apple? All right, so the first thing that I'm thinking is, what is this problem about? And it's about an apple and a watermelon, right? Okay, so my next thing that I need to look at is what information does this problem give me? Okay, so this problem gives me the information that the apple weighed 5 ounces and the watermelon weighs 20 pounds. That's a big watermelon. Okay, so now I know what the info is. So now I have to look for the question, right? So the question is asking us, how many more ounces did the watermelon weigh than the apple? Okay, so how much more did it weigh? But it's asking how much more did it weigh in ounces. So I'm gonna have to say, so the watermelon weighed blank ounces more than the apple. Okay, so let's go ahead and let's do the math. So step 1 says, find the total number of ounces the watermelon weighed. So since the problem gave us the weight of the watermelon in pounds, we have to convert that amount into ounces. So there are 16 ounces in a pound, so we have to multiply the 20 pounds times 16 ounces. So they've done it here with partial products. I'm going to show you with an area model because I know that's the way that many of you remember the best. So if each watermelon, or the watermelon weighs 20 pounds, and then I can take 16 and I can split it into 10 and 6. So if I multiply 10 times 20, I can multiply 110 times 2 tens would be 2, and then I have each one of these is a 10, so I have to make it 100 times larger. 6 times 20, so I can go 6 times 2 tens is 12, and then I make it 10 times larger, and then when I add those two partial products together, I get 320. Okay, so the watermelon weighed 320 ounces. So now to find the difference between the watermelon and the apple, I take the weight of the watermelon in ounces, which is 320, and I have to subtract the 5 ounces of the apple, and that will give me 315 ounces because 320 minus 5 is 315. So the watermelon weighed 315 ounces more than the apple. All right. Let's take a look at these two problems here, and then I will leave you to finish the work on your own. My dog is being crazy this morning for the math lesson. All right, so number 1, it says Stan has 4 pints of milk. Gianna has twice as much milk as Stan. How many fluid ounces of milk does Gianna have? Okay, so first, I have to figure out what is this about. So this is about milk, right? Second, I have to think, what math information do I have? So the math information that I have is that Stan has 4 pints of milk and that Gianna has twice as much milk. Okay, now I think about the question. The question is, how many fluid ounces of milk does Gianna have? So we have to figure out, Gianna has blank fluid ounces of milk. So that's how we're going to answer the question. So first we have to go, okay, so Stan has 4 pints of milk. Gianna has twice as much. So that's going to be times 2, right? So 4 pints times 2 is 8 pints. Now, so that tells us that Gianna has 8 pints of milk. Okay, so there are 16 ounces in a pint. So if I take 8 pints times 16, so I'm going to do 16 times 8. So I do 6 ones times 8 ones is 48 ones. And 8 times 110 is 8 tens plus 4 more tens is 12 tens. So that's going to be 128 fluid ounces. So Gianna has 128 fluid ounces of milk. Okay, so first I had to figure out how many pints she had, and then I had to convert the pints into ounces because the problem asked us how many ounces. All right, let's take a look at number 2. So number 2 says, Molly went to her grandma's house for 16 hours last weekend. This was 4 times longer than the time she spent at her grandma's this weekend. How many minutes was Molly at her grandma's house this weekend? Okay, so the question is about, or the problem is about time at grandma's, right? So Molly's time at grandma's is what the problem is about, okay? So now I look for the math information. So last weekend, she was there for 16 hours, okay? And then we know this was 4 times longer than the time she spent at her grandma's this weekend. All right, now we look at the question. How many minutes was Molly at her grandma's house this weekend? That's the question. So the answer is going to have to say Molly was at her grandma's house for blank minutes this weekend. And that's how we write the sentence that we're going to answer. So now what we're going to do is first we're going to figure out how many hours was she at her grandma's house this weekend. And then we have to convert those hours into minutes. So the problem says that that last weekend she was there for 16 hours, but that's 4 times longer than the amount she was there this weekend. So what I'm thinking is the time that she spent this weekend times 4 equals 16, right? Because the amount of time that she spent this weekend, 4 times longer equals 16. So I have to think to myself, what times 4 equals 16? I know that it's 4 times 4 that equals 16. So that means that she was at her grandma's house for 4 hours, okay? So she was there for 4 hours. Now, I have to know how many minutes are in 4 hours. Well, I know that there are 60 minutes in each hour times 4 hours. And so I know 6 times 4 is 24. And then I make that 10 times longer because I'm doing 6 tens times 4 is 240. So Molly was at her grandma's house for 240 minutes this weekend. Okay, boys and girls. So remember, as you're reading the problem, you want to read each problem 3 times. You're looking for what is the problem about, what is the math information that you're going to use, and then what question are you trying to solve. Pay attention to the units that it's asking the question in, because many times in these problems, you're going to need to convert to a different unit than what the math problem gives you. All right, good luck. We'll see you for our lesson tomorrow.